Hello, we are Group 10, and we're presenting our final project, Stack Overflow Annual Survey Mining. And our members are Li Chongchen, Cherry Lin, and Benden Demonte. Our motivation is to provide information for students that want to join computer science or people that want to switch their career into programmer or CS-related jobs to help them better understand what they can be looking into and what they can be what outcome they can expect. So we focus on 5 output. The first one is how many professional programmer graduate from computer science background. Secondly, the most IDE used by developers. Third, the ranking of used programming language. Fourth, average developer salary in different country. And fifth, average salary in different educating level in the United States. Uh, data set we are using is an annual survey from Stack Overflow from 2017. And we use the following columns: professional, major, IDE used, have worked language, which means the language that is used by a programmer, country the programmer belongs to, the salary, and their education level. And the salaries are all converted to United States dollar for comparison. Our design goal is to utilize the Amazon Web Service scalability and Hadoop parallelism to help parallel the process of the following. The first process is to extract useful data from the CSV file. We parse the data line by line, and we aggregate the collected data. We might group them by country, education level, or background, and then we calculate our result accordingly. And the combination of AWS and Hadoop allows us to evaluate in different kind of like input size and machine numbers can vary with the same MapReduce program.
So now I'm going to talk about the detailed design of our MapReduce program. So regarding our first problem, so we first use the map to read the input data set one line at a time and get the value of professional column. And if it is a professional developer, we write it to context and also write the corresponding major. And in reduce phase, we get the number of all professional developers whose majors are CS related and divided by the number of all professional developers. So the second problem is the most ID used by developers. So we first use map to read the input data set and get the value of ID column and separate by the symbol to get the specific ID name. So we then write this ID names to the context. And in reduce phase, we get the number of users of each IDE and sort them by their values. So the third problems follow the same mechanism as the second one. And fourth and five are the same. So let's talk about the fifth problem, average salary in different education level in USA. So we first use map to read the input data set and get the value of country column. And if the respondent is from USA, we get the value of education level and the value of salary column. We write this value to the context. And in reduced phase, we get the average salary of respondents of the same education level.
All right. The above summarize how we program our program logic to generate the 5 output we want. And for the hardware and system setup, we're talking it right now. The implementation of our application, the core idea is we want the best scalability with least configuration for us. So we decouple the name node from worker nodes totally in the Amazon Web Server. And then we want to create a clonable AMI image so we can fast and like solid to replicate as many worker node as we need. And all the AMI has a setting pointing the worker node to the same name node. Also, along with the SSH private key login credential into the AMI image. And then we manually add the only thing left for us to do is to manually add the new DNS created by the AWS into the name nodes worker list. And so by properly configuring Hadoop, what we actually mean is we merge all the settings for name node and data node into the same configuration folder. And this won't interfere the working the functionality of a worker node, since a worker node is launched to be into a worker node. So we can either launch a node into a worker node or a name node. And the setting is directly pointing to the same name node we predefined. And so this created a clonable image that helps us quickly scale up our worker nodes and help us complete the evaluation. And for the program we choose, we want to see the most out of the MapReduce performance. So first of all, we need a large enough file to map, and our original data is only 93 megabytes. So we replicated them 89 times to around 8 gig file size. And we want to see enough amount of key so the reduce can be done multiple times. And so we chose the program that contains a lot of key at the end. So the evaluation, we evaluate our MapReduce program using 3 scenarios. In each of the scenario, every one machine is a T2 micro instance with 1 gig RAM and 20 gig hard drive. The first evaluation is using the same input file size with a variable machine number. So we use this at 8 gig file size with machine number varies from 4 to 10. The second test is using the same machine number with variable input file size. So we use constantly 4 machine with the file size varies from 930 megabytes to 8 gig. The third one we're going to test about is the fault tolerance. So we want to see if we kill one node after the job starts for 30 seconds, how much it will impact on the performance. The first one is the cluster size and the performance on different cluster size. So the improvement is better. From the graph, we can see the improvement is better when the cluster size are small. So from 4 to 5, we can see a 58-second performance improvement at the first. But from cluster size 9 to 10, we only see 14 seconds of the performance improvement. While changing the file size with the same set of cluster, the performance are more predictable and are actually pretty linear to the size of the input file. So we tested from 10 replicas to all the way up to 80 replicas, which is 7 gig file size, and the readings are shown on the graph. The third one we test is fault tolerance. The graph shows that the first one is without kill, which means the original time the system runs before the job is complete without killing any nodes. The red one is killing one node after the job has started for 30 seconds. The orange one is the job run using the number that is already killed. So for 10 nodes, the orange one means start the job with 9 nodes without killing any nodes into it. And we tested it in 2 scenarios. The first one is using only 1 replicas in the HDFS, and the second one is 3 replicas in HDFS. And in 5 nodes, we can show that there's a significant difference if we have multiple replicas that increases the fault tolerance. So for 5 nodes, if we have only 1 replica and we kill 1 node during the process, it actually increases the time needed a lot. But if we have 3 replicas, it actually limits down the time and still performs better with running originally with 4 nodes.
Okay, so now I'm going to talk about the result output of our MapReduce program. So the first one is how many professional programmers that graduate from the computer science background, and we calculate from the original data set that is approximately 70% of the total professional programmers. And the second one is the most IDE used by developers. And you can see that the most used is Visual Studio and in this survey. And the third one is the ranking of used programming language. And we can see that the most popular like Java, Python, JavaScript, and PHP, C are showing in the top 10 of our ranking. And the average developer salary in different country. And notice that it is in US dollars and annually. So United States has the highest average developer salary among all countries, and we only show the top 10 ranked countries, and but actually there are much more countries. So the average salary in different educating level in USA. So in general speaking, we can see that higher the degree, higher the average salary of professional developers in USA.
For the conclusion of our application, our model shows that using the same size of input file, the size of the cluster does improve the performance. However, the ratio of improvement gradually grows smaller at larger cluster size. Secondly, compare to the same machine size with variable file size. Our graph shows the time needed for calculation has a linear growth with file size. Our fault tolerance shows that on failure of one node, the lost work turns into extra work for other node to complete, and somehow in a last replicas setting, it may create a more work, it may drag down the performance. But if the replicas numbers are set properly, it has a higher fault tolerance rate and thus does not impact on the performance comparing to only one replicas created. From our result, currently 30% of the professional programmers does not come from a CS background. So we can fairly say the CS uh, working environment is still very welcoming for non-CS background people, and is worth giving it a try. As for working country, considering only salary, United States has a better average payroll comparing to other country. Uh, the most used IDE includes Visual Studio, a very powerful IDE, but also Notepad++, which is a very lightweight text editor. So as a programmer, we want to say that there is no really a best editor for coding, but there is a most suitable editor for you to work with. And that is our Group 10's final project. Thank you for listening.